Question number 20, it gives us a slope field and it gives us some derivatives which will generate this slope field. So there's two perspectives we can take on this problem. We can look at it from taking a look at the answers and seeing what these antiderivatives might look like. Or we could see what kind of curve goes through these points and seeing what the derivative of that curve would match up with. So I'm gonna look at it from the perspective of what is these, try to match the antiderivatives of these functions with the slope field. So if I anti-differentiate A, I get a parabola. Okay, and I get a parabola, and it'll be shifted a little bit, but basically I'm gonna get a parabola. And when I draw my parabola in, really I can't see that fitting that curve because it's kind of going up and down all over the place. Okay, so that parabola doesn't seem to work. For sine, if my derivative is sine, my integral would have been negative cosine. Okay, so negative cosine looks like this. Okay, so negative cosine, that looks like it could be a possibility, but not really quite fitting those lines there. And if I take a look at the negative cosine, okay, and I move it over here, that doesn't really quite match, because notice that through here we should expect a slope of 0. It looks like it's not a slope of 0 through the axis. If it's negative sine, that would be a positive cosine graph. And again, same thing is if I draw my positive cosine in, the slopes at 0, x is 0, don't seem to match. Even if I move this thing up and down, it doesn't seem to have a good match with that graph. If the derivative is cosine, this graph would be sine. So if I sketch a sine graph through there, well, in this case, the sine graph looks like it's a fairly good match. Okay, and if I draw the sine graph, if I take that sine graph to the other side there, look at the other period of that. Okay, I'm just going to grab that. If I look at the other period of that, that doesn't look too bad either. Right? It looks like it could fit in that domain. Okay, so that is a possibility. So I'm going to put a mark next there. And if it was negative cosine, the derivative would be negative sine, so it would look like that. Well, that one, again, just looks like if I take a look at the slopes near the y-axis, it doesn't seem to match. So by the best match, I can get that. The other perspective would be just to see if I can follow the slope lines and see if I can draw some kind of graph. Okay, and the graph kind of looks like that. That's not really the greatest graph, but okay, if I draw a graph like that, that looks to me like a sine function, and then the derivative should be a cosine function. Okay, and so the cosine y prime would then be equal to d. So there's two different ways we can look at it. We can look at it from anti-differentiating this and seeing if those antiderivatives match, or we can see if we can check out this graph the function first and see if the derivative of the graph looks like one of these answers.